Problem 37, the fish problem. The length L in meters of a certain fish depends on time t, and it's modeled by L as f of t is 4 times t to the 2.99. And the mass m in kilograms is, we're going to think of this depending on L, the length L modeled by m of g of L. We don't know exactly what g of L is. Okay, so part A says what is Q is f of 4 minus f of 0. What does this mean in the context of this problem? F of 4 is going to be 4 times 4 to the 2.99 minus f of 0 is 4 times 0 to the 2.99. So it's just 4 times 4 to the 2.99. Now this particular value doesn't matter too much, but let's just say this is right here is the length of fish at time 4. This is the length of fish at time 0. If we're thinking of time 0 as, and we're told here, measure in years since birth, this is, we're going to assume the fish is 0 when it's 0 length when it's born, but this is just how much it grows. So, so our real answer to part A is Q means how much does the fish grow in the first 4 years of life. If we change this to be, f of 5 minus f of 1, that would be how much does the fish grow from 1 year of age to 5 years of age. Okay, then part B is asking us for f prime of 1. So this is going to be how fast is the fish growing at 1 year of age, with the units being something in terms of meters per year. The fish is growing at a rate of 1 meter per year, something like that. And that would be the meaning of f prime of 1. Part C is asking us for g prime of 4.87. What are the units here? So this is mass depends on the length here. So this would be if the length is increasing, the mass is also increasing. So the units here would be, the units on the mass we're told is going to be measuring kilograms, but it's not kilograms, it's kilograms per meter. So g prime of 4.87, how does the mass depend on the length here? If the length goes up by a meter, it goes up by so many kilograms. That's what's going on here. Okay, so that is part C. For part D, we are told dm over dl is equal to 4 when L is equal to 4. And we also can see here that that f of t when t is equal to 1, so f of 1 is equal to 4 times 1 to the 2.99. Okay, at what rate, measuring kilograms per year, is the mass of the fish changing in respect to time exactly 1 year after its birth? So m, I'm just going to recopy, m is g of L, but this L depends on time, like we wrote L is equal to f of t. L itself is a function of t. So how to take a derivative here, this is going to be a chain rule problem. So dm dt is equal to the derivative of g prime of L of t times the derivative of the inside function, L prime of t. Okay, and so we're given here, we need to figure out, we need to figure out what's going on here. Let's see, dm dt is equal to, I wrote 4 there. I should have written 7. Okay, 7. Don't mind that. And g prime of L of t. This is the thing we're going to try to solve for. This is, this is going to be our unknown. And then L prime of t. L prime of t is going to be, let's see here. It's going to be 2.99 times 4 times t to the 1.99. And so L prime of 1 is just 2.99 times 4. And so our unknown, the thing we're trying to solve for, the rate measuring kilograms per year that the mass of the fish is changing in respect to time, is going to equal solving this here, 7 divided by 2.99 times 4, whatever that crunches out to be. Okay, so that is the fish problem.